Hello, my people. We are now done with implicit differentiation as such, but your book includes something at the tail end of the implicit differentiation section. It is the derivative of inverse trig. And I know that you are just thrilled. You were thinking, what could be better than trig and implicit differentiation? Oh, implicit differentiation with inverse trig. That would be better. So let's say that we have something like y is equal to arcsine of x. And of course we remember that since I'm old school, I love arcsine, but that is the same thing as inverse sine. But that's, of course, function inverse and not multiplicative inverse. That is not the same thing as cosecant, right? An inverse trig function takes a ratio and turns it into an angle measurement, whereas a trig function takes an angle measurement and turns it into its corresponding ratio of sides. Well, you kind of look at that and you think to yourself, I don't know how to do that, but could I take the sine of both sides? Or let's just put it this way, could I rewrite that original equation like that? I think that we can. Well, let's go ahead and differentiate with respect to x, which of course is implicit differentiation. I know that that's going to be, if that's sine of stuff, then the derivative is cosine of stuff times the derivative of stuff. And the derivative of x with respect to x is 1. Okay, well that means that y prime is equal to secant y. Well, I happen to know what y is. Y is arcsine of x. And oh my gosh, that is starting to look awfully familiar. Okay, if I can deal with that, I know that arcsine is something that's going to turn a ratio into an angle measurement. And that ratio, of course, is arcsine over 1. Okay, so this right here implies an angle measurement. Let's call it alpha. And alpha, x over 1, is opposite over hypotenuse. And therefore this right here is going to be 1 minus x squared. Okay? And that's just using Pythagorean theorem in order to find out this other side. So if I wanted the secant, that's hypotenuse over what? The adjacent. And therefore, I know that it's just 1 minus x squared in the denominator. And therefore, that tells you that the derivative of arcsine of x is equal to 1 over the square root of 1 minus x squared. And now some of those tedious exercises that we did back during pre-cal are all of a sudden making a whole lot more sense. At least I hope they are, okay? Now, of course, the same thing can be done for cosine. But here's the thing. Cosine is going to be the same thing, except for when you take the derivative of cosine, you're going to get negative sine. So it really shouldn't be a surprise to us that the logic is going to proceed very similarly for cosine, with the exception that there is a negative introduced in there because of the derivative of cosine y is negative sine y. Okay, and if you want to do it on your own, by all means, go back through the same logic that we use, set up y is equal to arc cosine x, and change it into cosine y is equal to x, and go forth from there. And I think that you'll see it when you do it. Okay, so that's arcsine and arccosine. Okay, well that's a whole lot of fun. Let's go ahead and let's do arctangent next. I think arctangent's probably the next one. So let's do y is equal to arctan of x. Well, as you might suspect, tangent y is equal to x is how we're going to rewrite it. Now tangent y, when I take d dx, or I take the derivative of both sides with respect to x, right, I'm going to get secant squared y times y prime is equal to 1. Okay, so y prime is going to be cosine squared y when I divide both sides by secant squared. Okay, and therefore that's going to wind up being cosine squared arctan of x, or it might be a little bit nicer to go ahead and write it like that. That makes it a little bit more explicit, right? And I'm going to put the triangle right up here, okay? Now remember, okay, this right here implies an angle measurement that we'll call alpha. Now arctan, that ratio right there, because it's tangent, right, is opposite over adjacent. So opposite over adjacent. That means that this right here is the square root of x squared plus 1 if we do Pythagorean theorem in order to find out a variable expression for that hypotenuse. Now, if I'm looking for the cosine of alpha, that alpha, it's 1 over that radical, but it's squared, okay? And therefore y prime is 1 over x squared plus 1. Showing us that if we are asked for the derivative of arctan x, it is 1 over x squared plus 1. Now, you ought to suspect that this has a relationship to arc cotangent, and you would be right. Arc cotangent x, just like the arc cosine introduces a negative but follows the same logic, arc cotangent is simply the negative of arctan. So there's 4 of them that we've figured out. Okay? Now let's go ahead and do the last 2, secant and cosecant, before we start doing some examples. We have y is equal to arcsecant of x. Now this one, you're thinking to yourself, this one's going to be weird, because I remember the derivative of secant is secant tangent. So that's going to throw all sorts of weird things into the mix. And you're right, it does, okay? So secant y is equal to x, and I know that that means that secant y tangent y, y prime, is equal to 1 when I differentiate both sides with respect to x. Now, I know that that means that y prime is equal to cosine y, and then of course cotangent y. But I could have done that differently, right? Because really, secant tangent is 1 over cosine y. Tangent is sine over cosine y. Times y prime is equal to 1. So I could have recast y prime a little bit differently, and it could have been, cosine squared y, and then of course cosecant y. Either way, you're going to get the same. You're going to get the same answer. Okay. But this might actually help the squaring right here. That either way, it's going to wind up being the same thing because you did it by identity, right? And identities show you 2 things that are equal. So we know that this is going to be y prime is equal to cosine of arcsecant x over 1, cotangent of arcsecant x over 1. Now, despite the fact that there are 2 trig expressions right here, you're dealing with the same triangle. So you only have to set up the triangle once, right? Because this is the same angle measurement as that. Arcsecant x over 1 is the same as arcsecant of x over 1. It's still representing an angle measurement that we'll call alpha. Now, arcsecant is, of course, hypotenuse over adjacent, which means that this right here is x squared minus 1. Now, cosine of arcsecant. Well, cosine and secant are reciprocals of each other, so it shouldn't be a surprise that cosine of alpha is 1 over x. Okay? Now, cotangent is adjacent over opposite, and therefore this is, and therefore we wind up with that. Okay? Now, there are some books that actually put absolute value around that x, and that's probably helpful. But let's just go ahead and do the arcsecant. Okay, and of course, as we should expect, arc cosecant is just the negative, okay? And those are your last two inverse trig. Now, this video might be really, really helpful to go back and look over, because you can actually wind up doing it the old way, kind of like you can do logarithmic differentiation instead of memorizing the rules. Or if you forget the rule, you can go back and do logarithmic differentiation. Well, just like that, if you're given y is equal to arctan of, let's say, oh, I don't know, how about x squared over 2? And you're like, gosh, what's that formula again? Don't sweat it. Just do tangent of y is equal to 1/2 x squared. Secant squared of y is equal to x, okay? Forgot the y prime, sorry, remember this is implicit. And so we have y prime is equal to x times cosine squared y, or x times cosine squared arctan of x squared over 2, and then of course you can go on from there, right? We can go ahead and scratch out the squared right there and put it outside if we want, knowing that that is our alpha when we set up our triangle, right? That's our alpha. I almost did an infinity symbol. Whoops. Okay, and so we have opposite over adjacent, and so this winds up being x to the 4th plus 4, right? Okay, well, cosine of that angle is going to be opposite over hypotenuse, but then you're going to square it, so you're going to wind up getting x times 4 over x squared plus, or x to the 4th. Let's go ahead and do that again. X 4 x to the 4th plus 4, or if we want 4x over x to the 4th plus 4, and that should make sense to us, okay? Because if the derivative of arctan x is 1 over x squared plus 1, we should expect that arctan u is going to be 1 over u squared plus 1 times u prime. And that's exactly what this is, okay? This winds up being a simplified version of doing it formulaically this way, okay? So this video will probably be a good idea to hang on to it and look at this stuff once again right before, in the weeks leading up to the AP exam, because these are sort of the derivations of those inverse trig derivative formulas. In maybe 1 or 2 more videos, I'll run through some examples, okay, and then we'll sort of move on from there. After this is derivatives of logs and logarithmic differentiation.